So last time we were looking at this sales shipping example, and we ended up using this code from ChatGPT that had a for in loop. And I want to really understand what it does in this session. So if you remember, we used the min function, and we strangely, you might think, put in two arguments, and we mentioned shipping options twice. That's the name of the dictionary. So we say shipping options and then comma, and then we say key equals shipping options dot get. So we mentioned shipping options twice. We've already said that we're dealing with the shipping options dictionary, and then we say key equals shipping options dot get. We do cheapest price, we'll assign to that shipping options cheapest option. So that knowledge about which the minimum value is kind of wrapped up in the cheapest option variable, and then we feed in the cheapest option into our kind of picker. We have a picker to go and pick the value of the key from the dictionary. But you can see here it says for option comma price in shipping options dot items colon print option colon price. Now I think that's really interesting. So how does this work? Because So, good evening. I'd like to talk to you about a feature of the code I'm working on. First, take a look at my code. Okay, let's just give that a refresh. So, good evening. I'd like you to help me with a feature of the code, with a feature of some code which I'm working on. First of all, here is my code. There we go. Your code is well written, but it does contain a typo that will cause an error. Specifically, the variable name cheapest price has a space in it, which is invalid in Python. Variable names must not contain spaces. Here's the fixed version of your code. Okay, fine. Okay, cheapest price, there we go. Cheapest underscore price. Save that. Moving on. So they've renamed cheapest space price to cheapest underscore price, and they've added cheapest price calculation correctly. So my question is about the for keyword. Now, we have this structure which is for yada 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 in yada yada yada. That is a structure that you'll see again and again. It's called a for in loop, I think. Now, shipping options is the name of our dictionary. So you can see up here it says shipping options, and we've assigned to it this dictionary, so it's in curly brackets. So what we're doing is we're saying for option comma price in shipping options dot items, do this. Now, I know that we have a dictionary called shipping options, but when I look at this dictionary, I do not see option or price within it. Yet we say for option comma price in shipping options dot items. I was wondering how this sort of syntax works, or this sort of structure. So great question. Let's break this down step by step. The key to understanding what happens when you call the .items method on a dictionary and how Python unpacks data during its iteration. That is the key. Understanding what happens when you call .items, it's a method on a dictionary, and looking and understanding how Python unpacks data during iteration. So dictionaries in Python. A dictionary in Python stores key value pairs. Keys are unique identifiers for the values. Values are the data associated with those keys. Makes sense. In your code, shipping options is a dictionary that looks like this. So we have it all in these curly brackets, and we have one key called ground shipping, a second key called ground shipping premium, a third key called drone shipping. So we have keys and values. And my values are just variables: ground shipping price, ground shipping item, premium price, and drone shipping price. So the items method returns a view object that contains pairs of keys and values from the dictionary. These pairs are represented as tuples like this. So tuples have rounded brackets: ground shipping, 25.50, ground shipping premium, 125, drone shipping, 45.00. This means .items turns the dictionary into an iterable collection of key value pairs. Okay, the .items turns the dictionary into an iterable collection of key value pairs. It's really important that you know that. So it will be commas separating these things in rounded brackets. So iterating with for. When you write for option, comma, price in shipping options.items, Python 1 calls .items on shipping options, producing the key value pairs as tuples. 2 iterates over those tuples. 3. For each tuple, it unpacks the tuple into the variables option and price. Again, 1, it calls items on shipping options, producing the key value pairs as tuples. 2, it iterates over those tuples, which presumably just means considers them. 3, for each tuple, it unpacks the tuple into the variables option and price. Right, so, again, there's no rule that says the first thing in the rounded brackets is called option, and the first thing is price. No, what's happening is we've decided we're going to call the first thing option. We've decided we're going to call the second thing price. Okay, so there's obviously this rule that what you can do is name the two things within the rounded brackets. So we can say for x, y in shipping options.items. And what we're saying is, well, that is the first thing before the comma, and price is the thing after the comma. So unpacking in action. For the first iteration, the tuple ground shipping, 25.5 is unpacked. Option equals ground shipping, and the price equals 25.50, £25.50 or whatever, or dollars probably, dollars and cents. For the second iteration, the tuple this time is this. So that's a tuple, rounded brackets, two things within it with a comma. Ground shipping premium, 125. So that's unpacked. Option equals ground shipping premium. Price equals 125. This process repeats for all key value pairs in the dictionary. Why don't we see option and price in the dictionary? You're correct that option and price aren't explicitly part of the dictionary. Instead, option refers to the key of each pair and price refers to the value of each pair. These variables are created dynamically during the loop and are used to access and process the data from the dictionary. Okay, so here's a simplified example. Here's a minimal example just to illustrate the concept. So we'll have a dictionary, we'll call it my dictionary, my dict, and we'll assign to it this object which uses curly brackets braces. A:1, comma, B:2, comma, C:3. For key, comma, value in my dictionary dot items. Okay, and then we have a print line. And so you can see that the print line is referring to key, or referring to key here in curly brackets and value. So it has value in curly brackets. It has key in curly brackets. So we're making use of these terms that we've introduced. We're only able to do that, to have those words in curly brackets, because of this line here, where we've said for key, comma, value. And look at what it's saying. We have the F outside of the speech marks, remember, meaning this is going to be a formatted string literal. It's called a formatted string literal. And all it means is, some parts of the string are just a string, meaning we literally print key dot dot, key colon, we literally print value dot dot, but the word key is in curly brackets, which means we're going to go and grab the whatever the key is. So it's going to be key colon and then go and grab the actual key. It's going to be value colon and then go and grab the value. And we are only allowed to use those go and grab curly braces within a string if we put a little f on the outside of the speech marks. So we have to put a little f to say, look, I'm going to be using these things which go and grab things. It's going to be a formatted string literal. What would that output? Well, again, we literally have key colon. We don't literally have key. So we're literally going to have key colon. We're literally going to have value colon. And we can see that here. Key colon, value colon, key colon, value colon. And it's we go and grab the key. So key colon A. We go and grab the value. So it's value colon 1. Key colon B, value colon 2. Key colon C, value colon 3. Key dynamically refers to the dictionary keys A, B, C. Value dynamically refers to the corresponding values 1, 2, 3. Okay. So try to remember that you can't just say, let's try and, yeah, you can't just say, for option price in shipping options colon, because that looks pretty sensible, doesn't it? You've got two variables, you've got the name of your dictionary, it's called shipping options. You can't do that. You have to say, for option price in shipping options dot items. So we have to use that items function. Again, it has to be in shipping options dot items. Okay. Again, in shipping options dot items, and then we need, yeah, and then the colon. And then we have a print function. Okay, so let's just get to grips with that print function. So we say print opening brackets, and then we're going to have an F, and then we're going to have a speech mark, an opening speech mark. So try again. So it's F opening speech mark. Then option, so we have the word option in curly brackets and then a colon. So again, F, open the speech marks, and then option in curly brackets. Then after the curly brackets of option, colon, US dollar, and then we're going to put price, colon, dot to F. Again, price, colon, dot to F. Again, price, colon, dot to F. And price, colon, dot to F. Then a closing brace, then a closing speech mark, and then of course we close it. So again, F, so F, bring in the option, US dollar, price, dot to F, and then close. Question. So I have a question about one part of the code. I'm not sure why we're using 2F. Okay. Great question. So the colon dot 2F in your print statement is part of Python's string formatting syntax, and it controls how the price value is displayed in the output. Here's a breakdown. The format specification colon dot 2F has the following components. The colon introduces a formatting specification for the value. The dot 2 specifies that the value should be displayed with 2 digits after the decimal point. And the F indicates that the value is a floating point number. So again, the 2 and the F are doing different things. The 2 specifies that the value should be displayed with 2 digits after the decimal point, and the F indicates that the value is a floating point number. So it's not F for formatted string literal, it's F for floating point number. Now, price is a floating point number representing the cost of a shipping option. So if we put colon dot 2F, remember 2 digits, F floating point, dot 2F ensures that the price is always displayed with 2 decimal places, which is standard for representing monetary values. Example of behavior. Let's see how this works with different floating point values. Price has assigned to it 25. So if we do the print function, f string US dollar price, what we'll get as output is 25. $25. Remember so the dollar is we're literally using the dollar. This is confusing because in AWS we often use a dollar before curly brackets to mean a dynamic placeholder, but here we want a literal dollar. So F US dollar price, fine. But let's suppose that price had assigned to it 25.5. If we do the print function and we print F US dollar price, what we'll get as output is US dollar and then price 25.5. If we do price has assigned to it 25.56789 and we just do F string US dollar, bring in the price, so price with curly brackets around, we'll get as the output 25.56789. Here the number of decimal places varies depending on the value, which can look inconsistent, especially for money. So what we do instead is we say, okay, go and get price, so we have the word price somewhere within these curly brackets, but also notice how here there's no colon. We're not interested in printing a colon literally. We have price, and then we do colon dot 2 f. So 2 places on the floating point, in other words, 2 digits for the floating point. That's what we're saying in English. So .2f, meaning two digits after the floating point. So we say price and then colon and then our detailed instructions .2f. Price colon and then our detailed instructions .2f. Price colon and then our detailed instructions .2f. Now the output always shows exactly 2 decimal places, which is consistent and professional for monetary values. So basically the .2f, you can do it, what's the rule? You can do it when you're naming a variable. So here we've got a variable price, we've assigned to it 25, and because we're naming that variable, what I can do is then a colon and then .2f. So do make it clear to Python that you are about to say you're not continuing the name of the variable. So obviously that colon is a special character. You know, we can't have Python doesn't start looking, oh, where's price colon, and then it comes back with an error saying, oh, there's no price colon equals 25. There's price, I can see you've declared price, but there's no price colon. Well, of course, colon is a special character, and it means, hey, stop, we're finished naming the variable now, and now I'm going to give you some details about what I want you to do with that variable's value. And the .2f means I want you to only display 2 digits because it's a floating point. Okay. Okay. Let's have a look at this min function. So I was wondering if you might help me to understand the min function. I don't really understand why we have to mention the name of the dictionary twice in the arguments to the function. Because we say cheapest option equals min, and then we say shipping options, comma, key equals shipping options.get. The min function in Python can be a bit tricky to understand with the key argument, but it is a powerful feature. Let's break it down step by step. So what does min do? The min function finds the smallest item in an iterable. In this case, the iterable is the dictionary called shipping options. By default, for lists, the min function compares the items directly, e.g. numbers, strings. For dictionaries, min compares the keys, not the values, unless told otherwise using the key argument. Okay, and that's the crucial sentence. I'm going to read it again. For dictionaries, the minimum function compares the keys, not the values, unless told otherwise using the key argument. Why mention shipping options twice? The second shipping options appears in the key equals shipping options.get part, and this is where the magic happens. Key argument. The key argument specifies a function that determines how the items in the iterable are compared. Instead of comparing the items directly, Python calls the function for each item and compares the returned values. Shipping options.get. The get method for dictionaries retrieves the value associated with a given key. So shipping options.get for ground shipping returns the value for ground shipping. Shipping options.get, and if you pass in drone shipping as the argument, it returns the value for drone shipping, and so on. When you use key equals shipping options.get in min, Python finds the dictionary key whose value is smallest. Here's the process in detail. Min starts iterating over the keys in shipping options. And we know the keys are ground shipping in speech marks, ground shipping premium, and drone shipping. For each key, it calls, ground shipping premium, it calls shipping options .get to get the value. So that's what happens with the .get. We need that .get because we would be getting the keys by default. So we need to be focusing on the values, and so we use .get. For ground shipping, it gets ground shipping price. For ground shipping premium, it gets ground shipping premium price. For drone shipping, it gets drone shipping price. 3. It compares these values and determines which one is smallest. Finally, min returns the key associated with the smallest value. Why mention the dictionary twice? Well, the first mention tells Python to look at the keys of the dictionary, so shipping options, comma. But the second mention, key equals shipping options.get, tells Python to use the values of the dictionary to determine the smallest key. Here's an example to illustrate. Here's a simple example with a dictionary. So we'll say my dictionary, and we'll assign to it a dictionary. We have the key A, the key B, and the key C. Find the key with the smallest value. So we'll say the minimum function, and by the way, we'll package all the results in a variable called smallest key. And we'll say minimum, the first argument before the comma, is just the name of the dictionary, my dict. But then we need to say key is not going to be the keys. It's actually going to be mydict.get. So we have to go out of our way to make our voice heard. In this second argument, we have to go out of our way to make our voice heard and say, what do we want the keys to be? Here we want to say, I actually want the keys to be the values, the 10, the 5, the 15. So I'm going to say, well, to key, I'm actually going to assign mydict.get, and that .get actually goes and searches for the values. So if I do print smallest key now, which is the result of the minimum function kind of being put to work on that dictionary, it will just come back with the smallest one, which is B, and it will come back with the key. And that's really interesting. That's an important point as well. It will output the key. Because you might think, that might be a surprise to you. You might be thinking, well, hold on, I thought I said in the second argument we do key equals mydict.get, which means we look at the values. Yes, we do, to determine which is the minimum value. However, what we output is the key for that minimum value. So if we look at 10, 5, and 15, and I say to you which is smaller, 10, 5, or 15, or what's the smallest, you should say 5. We don't output 5, we output the key of 5, which is B. And that should make it clear to you that this has nothing to do with the output. Key equals mydict.get. That's to do with that's for the minimum function and the way it finds the minimum. So what happens here? So if we do minimum applied to mydict, that by itself would compare the keys A, B, and C alphabetically and say, well, A is the minimum in the alphabet. But if we do key mydict, key is actually equal to mydict.get, we're going to focus on the values and compare 10 and 5 and 15 because of the mydict.get being assigned to key. Okay, key equals key assignment operator. Key equals. How to think about it? If the minimum function is hard to follow, you can imagine it as 2 steps. 1, we transform the keys into values. So the key function turns keys into values. And 2, we find the smallest transformed value. Minimum then finds the smallest value among these values and returns the corresponding key. Let me know if you'd like a further example or explanation. That seems okay. And I think we're going to leave it there for now.